Hello, I welcome you all in this presentation related with the subject failure analysis and prevention. And we are talking about the failure analysis of the formed components. So, when the forming is performed, multiple kind of the defects are introduced under the unfavorable processing conditions. Sometimes the defects are also introduced due to the incoming raw material, and that leads to the presence of lot of defects even in the formed component. And sometimes the processing of the formed components also leads to the presence of stress raisers, and which in turn promotes the failure. So, in this presentation we will try to take the three different case studies based on the failures of the formed products occurring due to the different kind of the regions. Okay. So, you know that the failures of the component due to the few fundamental causes, which involves like deficiency in design or deficiency in the material or improper material selection, inappropriate manufacturing process and procedures which has been adopted. It can also be due to the improper assembly, improper service conditions, uh, and improper marking, and a lot of other aspects which can affect the serviceability, reliability of the components, and many times under inappropriate conditions of design, material, manufacturing, service conditions, assembly, etc., leads to the failure of the components. So, we need to analyze like what kind of the major factor would have contributed towards the failure, and that can broadly categorized if the really component is in the has been in service or component is still in the manufacturing stage. So, accordingly it will help in identifying the categorizing and grouping few fundamental causes of the failure as well, and accordingly we can take on the steps for the failure analysis. Say if the component ownership is still with the manufacturing company, then the kind of factors which will be there they will be little different than the case when the product ownership has been transferred to the customer and the product has been in use. So, inappropriate uses, abnormal service condition related factors are ruled out if the failure of the product is taking place in the manufacturing stage itself. Okay. So, depending upon the stage when the failure is identified, or we take the different kind of the categorization of the fundamental causes of the failures. So, in this particular presentation we will talk about what are the common the defects which are observed in the formed components and which lead to the failure. So, the three types of the defects about which we will be talking in this presentation, like one is there like the porosity or the gaseous defects are left in the formed products, and which are coming due to the incoming defective incoming raw material, or the product has been formed properly, but subsequently machining has not been done properly, and that is why few stress concentration and high stress concentration locations were led to the failure of the say formed component. And then like say the few formed components are further processed, like say the pipe manufacturing, the rolled sheets are used which are given the shape of the pipe or tubes through the joining approach. Okay. So, if that is the case, if the joining is not proper, then it will lead to the defective joints along the pipe length weld line, and that also promotes the failure if the joint is defective. Okay. So, accordingly in this presentation we will be talking about that the case of the formed components when the incoming material is defective. Okay. So, that is the case of like say the TMT bar failure occurred, and that failure occurred in form of the cracks observed during the bend test in the newly fabricated TMT bar. Okay. So, that occurred due to the that failure occurred due to the defective incoming raw material. Okay. And then one forced connecting rod, actually connecting rod is very common and popular component in the automobiles, compressors and many other locations wherever the rotary movement is to be converted into the reciprocating movement. Okay. So, the connecting rod, when the connecting rod fails, then we need to see really what would be the reason for that. So, in this particular case, the connecting rod was manufactured, and what was found, like the faulty machining had led to the higher stress concentration in the high stress areas, and that led to the failure. And then the pipe manufactured through the welding approach had defects, and so the defective pipe failure, which had pores and a few metallurgical heterogeneities, that contributed towards the failure. So, these are the three different kind of the case studies will be taking up in this presentation. So, whenever a component is received for the failure analysis, we need to keep all the aspects in mind. And what are those all the aspects? Like all fundamental causes of the failure must be kept in mind, and they should be considered fundamental causes of failure. Okay. So, there is a very wide range of these causes, which includes like deficiency in design. So, all the design aspects like the size, shape, the material, and the material choice which has been there, like it is the specified material or some other compatible material has been used. Then we have the manufacturing. So, we need to see really that appropriate manufacturing conditions have been used for that. And then under this we can have variety range of the conditions like casting, welding, forming, then heat treatment, surface engineering, anything which is used for making the product, that can be put under the manufacturing if it was proper, or if the manufacturing has contributed towards the failure. Then it is about the service conditions, the conditions under which the component has worked, whether those were as per the expectation or those were a little abnormal. Okay. And then also we have assembly procedure which has been adopted for making the entire component, and then maintenance, how regularly properly the maintenance has been adopted, and whatever the routine inspection and testing is required, whether it has been done or not, or if anything has been overlooked. So, all those things it must be kept in mind while analyzing a failed component from the failure analysis point of view. So, if we see, whenever there is a failure of the component, we need to keep everything, every aspect in mind. So, say here in this particular presentation, what will be talking, the defects in a formed component can arise due to the defective incoming raw material, which may be in form of like there is a big ingot, okay, having a large holes and the piping defects, and during the forming it is possible like these may not get closed completely, and if that is the case, then it will be leaving the filled sections, or not unfilled section, but the pores and the air pockets in the formed components. So, this is one of the possibility. Another is like there is a banded structure where the weak and the strong materials are arranged in a specific order. Okay. So, the bands of like weak material and then strong material, weak material and strong material, like that. So, it is possible like the bands are present. So, the weak materials, whenever they are present in form of band, they act as a notches, or they increase the stress concentration. So, in those cases the failure is promoted despite of the soundness. Okay. And so, in the formed component there is a possibility of having that kind of the defect also, and that will be due to the incoming defective raw material. So, this is one of the cases where the formed products having the gaseous defects or the porosity kind of the defects, or the banded defects which are weakening the formed products. Okay. Even if the forming is perfect, all the defects, if they were there in the incoming raw material, have been eliminated and the product is sound. Say the forging is expected to collapse the defects, distribute the impurities a little more uniformly, and improve the strength and hardness through the grain refinement and through the work hardening. So, the products are supposed to work very efficiently and effectively. Okay. But after the shaping and giving the desired size to the product through the forging or forming processes, okay, we have got the sound product. But the secondary processing to get the desired accuracy and the tolerance, if the machining has been done inappropriately, leaving behind a few high stress concentration zones, especially in high stress areas, then that can promote the fracture and the failure of the component, especially under the fatigue conditions. So, like say if the component is having a large change in cross section, which is very common say in the components like connecting rods. Okay, if there is a change in cross section, so these change in cross section must be obtained in such a way that whatever the fillets are there, they are of the high enough radius to avoid the stress concentration, because these are the areas which will be experiencing the high stress concentration. And in the high stress concentration areas, over and above, if the material is still left with some inclusions or some defects, then that will be certainly promoting the crack initiation and eventually failure of the component under the fatigue conditions significantly. Okay. And the another possibility is where, like say, the rolled sheets, thin sheets are being used for manufacturing the pipe. So, the sheet is like this, and the sheet will be formed first and then it will be joined by the welding. So, if the welding process is not proper, then it will be leaving behind the few defects along the weld line. Okay. The presence of defects in form of pores, inclusions, unwelded zones, or the inappropriate metallurgical segregations of the weak phases along the weld line. So, that can promote the cracking and the weakness of the weld joint. So, the failure of the pipes which are made using the rolled sheets. Okay. So, whenever in a component made by the forming process, whether it is made using, like say, the ingot has been used for making the TMT bars, or the forged component has been machined having the high stress concentration like the feed marks or inappropriate fillet radius or having the defects. Okay. Then what it does, like the presence of defect deteriorates the performance of the products, form products, cast products, or welded products in two ways primarily, because whenever these defects are there in those locations, the stress concentration will be high. This is one. And the second, at those locations load resisting cross sectional area will be reduced. So, the reduction in load resisting cross sectional area at those locations means the actual stresses are very high. So, the higher stress levels will be again promoting the crack initiation and then eventually failure. So, the presence of defect in any product will be promoting the stress concentration and the level of stress that will be experienced due to the reduction in load resisting cross sectional area at the locations where the defects are present, and that is why the failure will be promoted and encouraged easily. So, we need to analyze the things in light of this. Say, so these are the three typical case studies which I will be taking up, like the TMT, which means thermo mechanically treated, means we can follow like sequence of the plastic deformation, heat treatment, then the heat treatment and plastic deformation combination in order to achieve the desired size and shape, and apart from that desired metallurgical transformation in these bars. Okay. So, that the higher strength can be achieved. Okay. So, the TMT bars, typically these are manufactured using the rolling process, maybe hot rolling process, combination of the rolling and the high temperature exposure, and then these bars are supposed to have a very good combination of the mechanical properties in terms of the yield strength, ultimate strength to yield strength ratio, and the elongation. So, just for an example here, there are two categories of the two types of the TMT bar properties, like say Fe 500 offers the minimum yield strength of the 500 MPa, ultimate strength 545, and the ultimate to yield strength ratio 1.08, because what it indicates the extent of hardening of the material during the plastic deformation taking place while tensile test is performed, and the elongation is 12%. Okay. On the other hand, the Fe 500D, which offers again the strength of 500 yield strength and ultimate strength of 565, and the ultimate strength to the yield strength ratio 1.1 and elongation 16%. Okay. So, this is really a very good combination of the properties which is achieved through a combination of the work hardening and controlled phase transformation. Okay. So, these TMT bars typically have, if you see these structures also, there are ribs. Okay. So, the ribs will be providing a very effective gripping. Okay. And apart from that, there will be the two different zones, we can say three different zones. So, outer zone is usually made of the tempered martensite, okay, offering the very good hardness and the strength. Then the core is made of the ferrite and perlitic structure, while in between there will be mixture of combination of the martensite, perlite and the ferrite. Okay. So, this we can say as a transition zone, where the transition from the tempered martensite to the ferritic and perlitic structure is taking place, having mixture of all these phases. So, this kind of the combination of the microstructure helps in imparting the desired strength, desired combination of the strength and ductility. Okay. But so the during, so in one of the cases when the TMT bar being manufactured during the quality test, which is performed by typically bend test. So, while the bending, the bars were cracking. Okay. So, the cracking surface revealed the presence of lot of defects on the cracked surface or fracture surface, and therefore, the failure investigation was carried out by investigating its composition, microstructure, mechanical properties and the fracture surface studies, and also the soundness of the bars and ingots which were used for manufacturing the TMT bar. Okay. So, when the composition analysis was carried out, it was found that it is in light of the, it was as the expected the composition, but it had higher level of aluminum, silicon and the oxygen, which suggests that there would have been higher percentage of the inclusions and the gaseous presence in the metal. Okay. The microstructure showed the core of the TMT bar showed the perlitic one, and the surface indicated the martensitic structure. So, this shows the typical core of the ferritic perlitic or the perlitic one, and the in between transition zone, and the surface is made of the tempered martensitic thing. The properties were found a little lower due to the presence of the defects which were observed little later on the NDT studies and the optical studies of the fractured surfaces. Fractured surfaces study through the optical the field surface, and the TMT bar cross section was prepared and found that few holes and the gaseous defects were observed. That is what can be seen here, and the soundness of the bars and ingots were tested, and it was found that the blowholes porosity is present in the TMT bar. So, as a result of this, what was found, like the bend test during the TMT bar was failing during the bend test due to the presence of these inclusions and these blowholes and the porosity which was there in, and when investigation was carried out, it was found that the incoming ingot had lot of the piping defects which were not closed during the manufacturing process of the TMT bar, and which eventually led to the cracking and the failure of these bars. So, this is what typically shows the kind of defects which were observed during the studies. Okay. This is the another case study which talks about the failure of the connecting rod. So, the connecting rod is a typical component which is used, which actually helps in converting the rotary movement to the reciprocating movement. Okay. So, or reciprocating movement to the rotary movement. The connecting rod is one of the very important member in this process, and it is very common in IC engines. Okay. But as far as the operation is concerned, it is frequently subjected to the dynamic loading, fluctuating loading of very complex kind also. Okay. Combination of the like tensile, bending, compression. So, the when the component was inspected, and then it was found that the you see connecting rod will have the two ends, no, one side the size of the big end, like the piston side end of the connecting rod is bigger than the other side. Okay. So, the failure occurred from the piston side end. So, the failed connecting rod was observed visually, and it was found that the failure occurred from the fillet of the big connecting rod end. Okay. So, analysis was carried out considering that structural design and material dynamic loads, so which were acting, chemical composition, microstructure analysis, hardness, tensile test, scanning electron microscopy, fractography, and FE analysis, and fatigue conditions, because the connecting rod is exposed to the fatigue behavior. So, the fatigue crack growth rate was also studied using the sinusoidal load, using at a constant amplitude. So, in this spaces, this is the typical diagram. What it shows, like this is the small end, this is the big end, and here you can see the change in cross section. So, this change in cross section is managed very effectively through the proper fillet. If this proper fillet, so this is the area also, because of the change in cross section, this area uh, corresponds to the high stress area. Okay. In this high stress areas, if there are a high stress concentration due to any reason, like the fillet radius is not proper, or if there are defects in this zone, then this will promote and trigger the cracks easily. So, when the failure analysis was carried out, it was found that the failure occurred due to the low cycle fatigue conditions based on the fracture surface morphology, and it was observed that initial crack triggered from the high stress area concentration, that was the fillet. So, the fillet was not found to be of proper due to the improper machining actually, which was used for fabrication of the connecting rod. And another thing which was important, like the connecting rod manufactured by the cast steel, not the forged steel. So, this was the another aspect which was found, and the steel had many inclusions of the alumina, silica, and iron oxide. So, if the defects are present, if these inclusions are present, especially in the high stress areas, say here you have feed marks or improper fillet due to the machining, and in these locations in vicinity of that, if we have inclusions, then these simply will provide the areas of the weaknesses also in the area of the high stress concentration. So, this combination, the weak areas clubbed with the high stress concentration areas, that will be leading to the initiation of the crack easily. So, the inclusions near the fillet act as a stress raiser and promotes the crack initiation easily. So, additionally, when the fatigue crack growth test was performed, it was found that it is significantly higher than that is expected for this kind of the steel of which connecting rod was made, and Paris constant for this was found to be 5.2, otherwise usually it is 2 to 3 for normally steel. So, the crack growth rate was found to be significantly higher than the normal and the expected one, and this was also attributed to the presence of the defects. So, if we see this case, there are three main reasons: improper machining resulted in the improper fillet, and which led to the higher stress concentration, and especially the presence of inclusions in the high stress zones of the high stress concentration areas, that led to the crack nucleation and their growth by the fatigue. So, if there is a static load, then probably these high stress concentration areas, these defects can be tolerated to some extent. But if the component is subjected to the fatigue, then these the weak areas, stress concentration areas, these defects promote the failure very easily, especially under the fatigue condition. So, it is very important that the material is in good condition, proper machining has been done, and the component is free from the stress raisers. So, the third case study, so here you can say the connecting rod failed prematurely, and for the failure analysis, these were the different approaches and the stages which were used. Okay. Then now this is the third case study where the failure of the pipe and tube was failure analysis of the pipe and tube was done, and in this case say the failure of these pipes and tubes which were made of the zirconium alloy. So, these pipes and tubes failed along the weld center line through the bulging. You can see the crack is running along the weld line. So, this failure analysis was performed using the visual inspection, composition, microstructure, mechanical properties, fracture surface, and the NDT. So, when these things were done visually, when visual inspection it was done, it was observed that the fracture occurred from the weld center line of the pipe and which had pores, and microstructure composition was as per specification. Microstructure of the joint of the especially the weld joint shows the bended structure and the center line cracking and pores, and the mechanical properties were as expected, but with a little lower ductility due to the presence of the defects, bended structure and the porosity, and the sound NDT test showed the porosity and the holes and the pores and defective zones were found on the fracture surface. So, this is what we can see here, the defects are in the welded region in the pipe. Okay. This is the process of making pipe, like the flat sheet is rolled. Okay. So, once the rolling is done in the shape of pipe, then these sheets are subjected to the welding. So, the next stage is the welding process. So, when the welding is done, thereafter it is polished to give the desired the shape. If the welding process is not proper, then it will be leading to the defects in the weld line. So, here we can summarize whether the component is made by the forging or rolling process. If it is left with the defects of any kind, like say in form of fillets, in form of the gaseous defects, inclusions, then those will simply promote the stress concentration and form the weak zones which will promote the failure of the component easily, and the failures are more predominant if the loading is fatigue. Thank you for your attention.